Now we understand what are we going to study. We are going to study something about the machines, and there is going to be another important term called structure. All right. There is a definite difference between the terms machine and the structure. A structure, let us see the definition of structure. A structure is an assemblage of number of resistant bodies having no relative motion between them, right? You can see the component, the diagram given here in the slide here, right? Three components are attached together. Component 1, 2, 3, they are numbered, and all the components are joined by means of a bolt and nut, or by means of rivet, or by means of screw, right? So when the three components are attached together in the same fashion given in the diagram, you cannot expect the transmission of energy from one component to another component, right? So don't forget that I name it as component, not a link or element. So if the component is said to be a link or element, it has to transmit the uh, movement, that is, it must transmit the force from one component, from one part to another part. All right. Now we see the difference between the two concepts, machine and structure. A relative motion exists between its parts in the machine components, whereas no relative motion exists between its members. For example, if the two components are attached together, if there is no any transmission of energy from one component to another component, then that part is called as a structure. Whereas if there is a relative motion that exists between two components, then that component becomes a part of a machine. And energy can be transferred through the components in the machine, whereas the energy is not transmitted and the energy conversion does not exist in the structure. And links are meant to transmit motion and forces in the machines, whereas for the structure, the members are meant for carrying loads only, having straining action. We can have a number of examples for the machine. We can have a scooter, car, lathe, shaper, electric fan, electric motor, all come under the title of category of a machine, whereas the roof truss, building, bridge, all come under the category of the structure. Now you can get the difference between the machine and the structure. Kinematic pair is going to be the next topic. We discussed something about the link or the element, which is a single component of a system of components or system of a kinematics. If a component is connected to its nearest component or to the next component, then that combination is called as a pair. And if the relative motion is transmitted from one component to another component, then the kinematics play a major role here, and that pair is called as the kinematic pair. So a pair is a joint of two elements that permeates relative motion. When any two links or elements are connected in such a way that their relative motion is completely or successfully constrained, they form a kinematic pair. We can have a number of examples here. Say, for example, crank and connecting rod in the internal combustion engine become a kinematic pair, and connecting rod and piston in the same example for the same internal combustion engine become uh, the example for a kinematic pair, and piston and engine cylinder is going to be the another example. You can see that there are only two components, and these two components become a pair, and if one component is capable of transmitting the energy to the other component, then the pair can be called as a kinematic pair. Now we will see what are the classifications behind the kinematic pairs. It can be broadly classified into three segments. One is based on the type of the contact, next one is based on the type of the relative motion, next one is based on the type of the constraint. We'll see one by one in the subsequent slides. Based on the nature of contact or the type of contact, a kinematic pair consisting of two components can be classified into lower pair and higher pair. Based on the nature of relative motion between them or the type of relative motion, the kinematic pair can be classified into a sliding pair, turning pair, rolling pair, screw pair, or the spherical pair. Based on the type of the constraint, a kinematic pair can be called as a closed pair or the unclosed pair. We'll see the definition of each and every type of kinematic pair and every classification. We will continue in the lecture number 2. Please stay tuned. Thank you for watching this video.